Hello everyone, my name is Evandro Miguel Cuchera and I will present the paper QBMetrics, a tool for evaluating and comparing document schemas. The outline of presentation is introduction, context of the work, QBMetrics tool, demonstration, and conclusions. Introduction. Relational database, or RDB, are widely used to store data of several types of applications. However, they do not meet all requirements imposed by modern applications. In these scenarios, NoSQL document stores emerge as an option. They differ from RDB in terms of architecture, data model, and query language. RDBs and document stores will be used together, being necessary to investigate strategies to convert and migrate schema and data between them. Different approaches have been presented to convert RDB to NoSQL document stores. Some of them consider just the structure of the RDB in the conversion process, while others also consider the access pattern of the application. However, neither approach is concerned with the evaluating and comparing the structure of the output document. So, how to decide which is the best document structure for the application? In this paper, we present a demo of the QBMetrics tool, which is used in RDB to NoSQL document conversion process. QBMetrics provides a graphical interface to calculate query-based metrics that assist on the choice of a most appropriate target NoSQL schema. The tool uses direct acyclic graphs, or DAGs, to represent both the target NoSQL schema and the set of queries, where the vertices are entities and the edges are relationships. This demonstration will show how the tool is used to calculate metrics to evaluate and compare candidate and target NoSQL schemas. Context of the work. We created an approach to convert RDB to NoSQL nested modules. As in the conversion process, it is possible to structure the RDB entities in several ways to represent the NoSQL schema. Here we presented an approach to assist the user. So we can see an overview of the approach, and the approach is composed by 3 steps. In step 1, DAG creation, the user creates a set of DAGs to represent the target NoSQL document structure, which is an abstraction to represent a NoSQL schema here. In the step 2, evaluation, the user defines a set of queries that represent the application access pattern and calculates a set of metrics to measure the coverage provided by the schemas to help decide the best one. In the final step, data migration, the set of DAGs, or a NoSQL schema, is sent to Metamorphosis framework, our data transformation framework that convert each DAG in a set of commands to read, transform, and persist RDB entities as NoSQL entity. So in this paper, we are presenting the QBMetrics, a tool that supports all this process. The process of creating the NoSQL schemas and queries as DAGs, and calculate a set of metrics to assist the user in the process of evaluating and comparing document schemas before data migration. Now I will introduce the QBMetrics tool. QBMetrics architecture. The picture below shows the architecture of the tool. The architecture is composed by converter and metrics modules. The converter modules define a conversion process, as we can see in the picture, encapsulating the input RDB properties, the set of target NoSQL schemas, and the set of queries. Schemas and queries are represented as DAGs. In our approach, each DAG lists a set of RDB tables which are transformed into one NoSQL entity or document structure. In the picture below, we see 4 DAGs: DAG customers, orders, order lines, and inventory, where the vertices are tables and edges are the relationship between tables. So a DAG is used to specify the conversion process of the entities, where the root vertex represents the NoSQL entity and the other vertices the nested entities. A set of DAGs can be seen as a NoSQL schema. In the picture, we see the mapping between one DAG and a NoSQL collection. For example, DAG customers is mapped to collection customer, DAG orders is mapped to collection orders, and so on. So a NoSQL schema can be defined as a set of DAGs. We represent queries as DAGs, where the DAGs aims to represent the query access pattern. In our approach, we define the rules to convert an SQL command to DAG. So below we see some examples of mappings. We can see select statements with 1, 2, and 3 tables and the respective DAGs, where the vertices represent the query tables and the set of adds represent the join condition between query tables. The metrics module receives as input a target NoSQL schema and a set of queries. As schemas and queries are represented by the same format, we can objectively evaluate and compare them. Metrics. We define 6 metrics to measure the coverage that a NoSQL document schema has in relation to a set of queries. The user can measure the coverage relative to a given schema collection or to all schema collections. We define dir edge and all edge metrics that measure query edge coverage against the schema or collection edges. We define the metrics path, subpath, and indirect path that measure query path coverage against the schema or collections path. And finally, we define the graphical metric that returns the smallest number of collections required to answer a given query. We also define 2 scores used to rank the input schema. The first one is named query score. It is calculated for a given metric and a given query. Here we can see the definition of a key score for metrics dir edge, all edge, and graphics. So here it is the same value returned by the metrics, as we can see here. For the metrics path, subpath, and indirect path is a unique value and is named as paths. It returns the highest value among the 3 metrics, considering the depth of each path and an additional weight. The weights are used to set up a priority between path, subpath, and indirect path metrics. The schema score denotes the schema score for a given metric. So S-score is the sum of the key score values for all the metrics, where each query has a specific weight. For Heckel's metric, the S-score is a little different. It is a ratio between the number of queries and the number of collections required to answer them. A schema that answers all queries through only one collection has S-score equals to 1. To summarize, the key score shows the coverage provided by the schema for each query, where we can identify which queries require the most attention or are not covered by the schema. The S-score provides an overview of how well the schema fits the query set. We use the metrics and scores to evaluate and compare NoSQL schemas. A broader definition of metrics and execution of experiments is present in the paper Query-Based Metrics for Evaluating and Comparing Document Schemas at the CASE conference. QBMetrics demonstration. The tool's demonstration scenarios consist of converting an existing RDB to a NoSQL document. So first of all, we select an input RDB. In this demonstration, we use only the tables orders, order lines, and customers. Then, in step 2, we define a set of candidate NoSQL schemas. As we can see in the picture, we see the schemas A, B, and C. Then we define a set of queries that represent the application access patterns. Both schemas and queries are represented as DAGs. And in step 4, we calculate the metrics. Okay, so the objective here is answer the question how to identify which schema best covers the input queries. Now we will demonstrate the use of a tool considering the scenario presented. So in this slide we see the main screen of the tool. We see the steps A, B, C, and D. In A, the input RDB connection parameters are provided. In B, one or more NoSQL schemas are created from the entity of the RDB. The process is manually defined by the user. Then in C, queries that represent the application's access pattern are defined. And finally, in D, the metrics are calculated. In B1, we see the screen to create a NoSQL schema. Each schema consists of one or more collections of documents represented as DAGs. In example, we see the schema C that is composed by the collections customers and orders. In B2, the user defines the structure of the collection. So in the step 1, user add the RDB tables as DAG vertices. And in step 2, the user add the edges between the entities. And in step 3, we can see the structural information of the collection. Okay. In the figure below, we see a graphical representation of schema C, composed by the orders and customers collections, where orders collections has an array of embedded objects to nested order line entities. Creating queries. Both collections and queries use DAG-based abstraction. So the process of creating queries is similar to the process of creating collections. We define 3 queries shown as DAG paths in the tool. We can see all the queries in the step C. So after defining the NoSQL candidate schemas and the set of queries, in the step D, the user can calculate the metrics. This slide shows the metrics results. The tool provides a set of reports where the user can filter the results and set the weights for the metrics path, subpath, indpath, and for each query. Below, we see the query coverage results by schema. We can see the schemas A, B, and C. Through this information, the user can identify which queries require more attention or are not covered by the schema. The key score values are calculated considering the paths and queries weights, allowing to establish priority to calculate the score of the queries. The S-score provides an overview of how the schema fits the query set. For example, in schema C, there are path and subpath coverage for the queries 1 and 3. Dir-edge and all-edge show if the schema entities are related to each other according to the query DAG, here. And query 2 needs to join 2 collections for answer it. So, through these results, we can compare different schemas in relation to a given access pattern. Analyzing schema score. If we analyze only S-score field, schema A has the highest S-score for paths and dir-edge metrics. Schema A has closed access pattern to the query. The schema C has the second highest S-score for paths. However, it has the lowest S-score for hack goals metric. This means it's necessary to join documents from different collections. And schema B has the lowest S-score for path and dir-edge metrics. However, it is not necessary to join collections to answer the queries. So, the purpose of the tool is to assist the user in the process of choosing the appropriate NoSQL schema. Experiments performed show that the tool is an interesting starting point for planning the migration of data from RDB to NoSQL. And finally, conclusions. In this demo paper, we presented the QBMetrics tool to support the conversion process from RDB to NoSQL document. Based on an input RDB, the user defines a set of candidate NoSQL schemas and a set of queries that represent the application access patterns. Both schemas and queries are represented as DAGs. The tool calculates a set of metrics that measures the coverage that the schema provides for the set of queries. This information is used to decide which schema is most appropriate for the required access pattern before migrating the RDB data to NoSQL. As a future work, we intend to extend the set of metrics to consider aspects related to the implementation effort and execution time of the queries in the target database. The reference of the work. Thank you very much.